Good morning, students. Today we are going to discuss different types of energy. And here you can see the picture of different types of energy. That is mechanical energy, sound energy, electrical energy, light energy, heat energy. All are different types or forms of energy. In this chapter we are mainly dealing with mechanical energy. And mechanical energy is the energy that is possessed by an object due to its motion or due to its position. So mechanical energy can be either kinetic energy or potential energy. So first we can discuss the gravitational potential energy at a height. The gravitational potential energy of a body at a height above the ground is measured by the amount of work done in lifting it up from the ground to that height against the force of gravity. So now consider an object which is placed on the surface of the earth, and we are applying a force which is equivalent to the weight of the object, that is mg, and we are applying this force, and due to that force we are lifting that object to a height h. So now the position of the object is height h from the ground level. So from this you can calculate the work done. What is work done? Work done is force into displacement or distance, force into distance. So in this case work done is equal to force. Here force is weight of the object, that is mg, and the distance is height h. So now you get the expression for work done, that is mgh. So this work done is stored on the object as potential energy of the object. So from this expression you can find that work done is equal to the potential energy of the object. So here the potential energy of the object is mgh, and we are representing potential energy using the letter U. So it is a small derivation for finding the gravitational potential energy at a height h. In this case we have taken the potential energy at ground level is 0, and it is our freedom. We can take anywhere the potential energy can be taken as 0. Here we have taken the potential energy at ground level is 0, but the absolute value of potential energy at ground level is not 0. In the case of absolute value of potential energy, the potential energy is defined as the work done in bringing an object from infinity to that position. And here you are using the expression F is equal to G m1 m2 divided by r square. But now you don't need to bother about this equation. You will study it in the higher class, and now we need the equation, that is potential energy equal to mgh, and here we have taken the reference frame, that is the ground level, as 0 potential energy, and we get the expression, that is gravitational potential energy U is equal to mgh. Now we can discuss about kinetic energy. The energy possessed by a body by virtue of its motion is referred to as kinetic energy. And you know the expression for kinetic energy, that is kinetic energy is equal to half mv square. That is kinetic energy is proportional to both mass and its velocity. Now we are going to prove this equation. For that we are considering an object of mass m, and its initial velocity is 0. Initial velocity vi is equal to 0. Now we are applying a force, and due to that force it is moving in the horizontal direction, and after time interval t its velocity become vf, that is v velocity, and the object have traveled the distance d. Now you know the laws of motion, that is v square is equal to u square plus 2as, And here v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. And here you can rearrange the equation and form 2as is equal to v square minus 0, and here the initial velocity of the object is 0 and the final velocity is v. So from that equation you can write 2ad is equal to v square minus 0. Here d is the distance traveled by the object after time interval t. So from this expression you can write acceleration a is equal to v square divided by 2d. Now we know the equation of force F is equal to ma. From that equation you can get the value of acceleration a, that is acceleration a is equal to F divided by m. So you can substitute that value and form the equation F is equal to m into v square divided by 2d. And we know that work done is equal to force into distance, and here we have calculated the value of force, so we need to multiply the value with the distance. So from that we will get the expression for work done, that is it is force is mv square divided by 2d and the distance is d. So you will get the value of work done mv square divided by 2 or half mv square. So it is the work done. And like the previous case, the work done is converted into kinetic energy. The whole work done is converted into kinetic energy. So we have derived an expression for kinetic energy, that is kinetic energy of the object is equivalent to half mv square. So for deriving this expression we have used the work energy theorem, that is the work done on the object is converted into kinetic energy. The work energy theorem states that the work done by the sum of all forces acting on a particle equal to the change in kinetic energy of the particle. And here the object is moving in horizontal direction, so there is no possibility of changing the energy to potential energy. So the total force we are applying is total, it is fully converted into kinetic energy. And we can derive the work energy theorem using the laws of motion, that is v square is equal to u square plus 2as. From this expression we can find the value of acceleration, that is v square minus u square divided by 2s. And like the previous case we are taking f is equal to ma, and here the value of acceleration we have already find v square minus u square by 2s. So substitute that value and you will get the expression for force, that is m into v square minus u square divided by 2s. And here the applied force is equal to the work done, so you can write the expression for work done, that is work done is equal to force into distance. So here we have calculated the value of force, so force into distance, by substituting that value you will get this expression. From this expression you can rearrange and form this expression, that is work done is equal to half mv square minus half mu square. Here v is the final velocity of the object and u is the initial velocity of the object. So from this expression you can understand that work done is equal to the final kinetic energy of the object minus initial kinetic energy of the object. So this is work energy theorem, that is work done by a force is equivalent to the change in kinetic energy of the object. So we can discuss the numericals related to this portion in the next class. Thank you.